medical, scientific, professional, academic. Welcome to Midpresso Podcast.
Effects of nutrition and supplements on brain and cognitive functions. Part 1. Brain is one of the organs that consumes a record amount of energy. Regular nutrition, which provides the necessary sufficient energy level for the brain to function, remains a problem of an ongoing research. The search for universal sources of energy for the brain is aimed at solving many problems, from prolonging working capacity during the working day or additional doping for athletes to maintaining cognitive functions in certain brain diseases, such as, for example, Alzheimer's. Nutrition provides the brain with building material for the formation and functioning of neural connections. It is the food factor that mainly affects the plasticity of neurons, one of the most important protective functions that allows brain neurons to restore their structure after damage. For example, some diets high in seafood and algae provide the body with essential omega-3 fatty acids that affect neuronal plasticity, which also affects cognitive function. Other diets rich in glucose and saturated fat, high in calories, increase oxidative stress levels and decrease synaptic neuronal plasticity in cognitive function. It is an adequate diet that affects the functional abilities of the brain. In addition to regular nutrition, it is interesting to study recommendations for the use of additional stimulants for brain function, namely nutritional supplements and plant extracts. The functioning of the human body is directly related to the energy balance. Increased stress, both physical and mental, leads to overwork. Researchers distinguish between overwork and fatigue at the peripheral level, physical fatigue, and at the central level, mental fatigue. It is the regular central level overwork that can lead to impaired cognitive functions. Energy balance, peripheral and central level concentration of attention, and the effect of fatigue on cognitive functions have been studied quite thoroughly in sports medicine. Studies of the effect of nutrition and food supplements on brain function in athletes are of particular interest. Results in most sports depend on many components: physical form, physical endurance, performance, skill accuracy, speed of decision-making, motor control. One way or another, athletic performance is directly related to the coordination of the central nervous system with the periphery. Accordingly, fatigue occurs not only in the periphery, muscle and joint fatigue, but also affects the central nervous system, affecting cognitive functions. Cognitive functions in sports are reflected in the ability of athletes to respond to a dynamically changing, often unpredictable environment. These are mostly team sports. These sports require intense visual attention, quick executive responses, and rely on working memory to make instant decisions. Pesci et al., 2007. Many sources indicate that both physical and mental fatigue can impair cognitive task performance and reduce athletic performance. Goebel and Christie, 2017. But how does one measure cognitive ability in sports? Most of these indicators are tested in standardized computer tests, which does not always correspond to unpredictable sports situations. Therefore, the following tests are often resorted to in sports: simulated actions in golf, alertness and reaction time in football, assessment of possession of the ball, transmission accuracy in team sports, tennis serve. Impact of dehydration on cognitive functions. The effect of hydration status is fairly well understood in both sports medicine and other clinical disciplines. The essence of the results obtained is that dehydration and hyperthermia lead to short-term disruption of the blood-brain barrier, which in turn affects stability during exercise. Increased neural activity in order to maintain sustainable results. Decreased vigilance and working memory. Tension, anxiety, fatigue, decrease in visuospatial processing, disrupted planning. Amino acids, carbohydrates, and other active substances. Changes in the diet and adding certain amino acids open the possibility of manipulating the central nervous system, while enhancing the performance of the brain. Branched-chain amino acids, tyrosine, carbohydrates, and caffeine have such properties. Oral doses of tyrosine increase the circulation-off concentrations of epinephrine, norepinephrine, and dopamine both in the central nervous system and in the periphery. These substances activate the functions of the body during physical exertion and exercise. Adding tyrosine prevents stress-related cognitive decline, also occurring in wartime. Lieberman, 2003. Carbohydrate feeding is another strategy for impacting the central level fatigue. Hypoglycemia has been proven to negatively affect brain and cognitive functions. It is known that the brain consumes about 130 g of glucose per day. Most of the available glucose will be consumed by the brain while at rest. Glucose is stored as glycogen in astrocytes, nervous tissue cells that support neurons, and is broken down during a sudden request of the body during periods of increased neuronal activity, or during prolonged endurance exercise. Brown and Ransom, 2007. Also, during high brain activity, astrocytes can convert glucose to lactate, a product of anaerobic glucose metabolism, which in turn can also serve as additional fuel for the brain. Glucose plays a significant role in the regulation of cognitive function when attention is split between two tasks, or when task difficulty increases. Changes in episodic memory are also a consequence of dysregulation of glucose levels, which occurs more often in older people, triggering other aging processes. With a low level of carbohydrates in the liver, ketone bodies, acetoacetate and beta-hydroxybutyrate, are synthesized from fatty acids, which are used as a reserve fuel for the brain. This pattern is observed during starvation. Holdsworth et al., 2017. Therefore, triacylglyceride supplementation is thought to improve cognitive function by providing the brain with energy in the form of ketones, fat breakdown products. Holdsworth et al., 2017, Volek et al., 2015. It is undoubtedly interesting to follow the studies of the effects of nutritional ketosis, a state of carbohydrate starvation of cells, on cognitive outcomes in Alzheimer's disease. Low carbohydrate intake may improve memory function in older people with an increased risk of Alzheimer's disease. Volek et al., 2015. Caffeine. Caffeine has long been recognized as an ergogenic, a diet that improves exercise performance. Its structure is similar to adenosine. Caffeine easily crosses the blood-brain barrier and quickly neutralizes most of the inhibitory effects of adenosine on neuroexcitability and arousal. Therefore, in contrast to adenosine, caffeine causes an increase in the concentration of dopaminic acid, which in turn manifests itself in such effects as improved vigilance, increased attention, reduction of reaction time, performance improvement, ergogenic effect during long-term endurance exercises, improvement of executive control, increase in working memory, reduction of simple reaction time in working memory tasks, improvement of muscular endurance, improvement of mood, lowering feelings of anxiety. Less pronounced effects of caffeine are observed on memory and executive functions such as judgment and decision-making. Caffeine has been shown to be effective at low doses, 3 mg per kg of body weight. Recent studies by Beaumont et al., 2017 have shown that chronic low-dose caffeine intake induces tolerance to the benefits of caffeine in those who do not consume it. Caffeine can cause side effects such as tachycardia, nervousness, dizziness, and gastrointestinal symptoms in people who have not previously used it. All this can adversely affect performance.